Hello, Year 6, and I just wanted to welcome you along to my very first home learning video. At the moment, I'm feeling a little bit like this guy down here at the bottom. I'm a little bit nervous, a bit scared of technology, but we'll see how we get on. I hope that you're all really well. I'm currently sat in Oscar's bedroom because he's downstairs playing Fortnite on the computer, on the telly, so I thought I'd use his bedroom. So we are going to have a look at some of our new learning today, and we are going to be scientists. Now, going into term 5, we're going to be learning all about light and how it travels. And our new inquiry topic this term is, why are shadows important? So we need to be thinking about this question, and hopefully towards the end of the term we will be able to answer it. During this inquiry, we are going to be scientists, and we're going to be looking at light and how it travels. We'll also be looking at why shadows have the same shape as the objects that cast them. Some of you might already have a little bit of understanding about that because this topic is building on our prior learning that we've done in years previously. And we're also going to be artists, and we're going to be improving our mastery of art and design techniques. And that's going to be including drawing, painting, and sculpture. So this first lesson that we're going to be looking at is going to be all about how we see. And like I've put at the top there, this is term 5, it's week 2, although it's week 6 of lockdown. And we have a wall, which is we are learning to explain how light travels to our eyes. And below that, we have some success criteria, which is going to be, I can demonstrate that light travels in a straight line. I can create a model to show how light travels from a light source to your eyes or an object and then our eyes. And I can explain how we see things. During this video or in this lesson, I'm going to give you opportunities to pause the lesson so that you can complete the activities during it. I thought that was probably the best way to do it. So, I've created a page here of new vocabulary that you guys are going to need to know. Some of it you'll already know. So we've got light, then we have source, travel, straight line. We've got waves, which are like this, waves, and we'll kind of talk about that a bit more in a minute. And we've got vacuum, ray, beam, wave, photon, and energy. And then next door to the key vocabulary, I've put some of that key vocabulary, and I have written down the definition of what that means in the terms of the science and as being a scientist, what we're looking at today. So if you wanted to, at this moment in the moment in time in the video, you could stop the video and you could record this down in your notebook or on a piece of paper if you wanted to. Okay, so I have also found this really useful resource. It's a light knowledge organiser. I have sent it to the website to be uploaded onto our school home learning page. So on it, it has got that little bank of key vocabulary that I just showed you. It's also got some key knowledge and some diagrams and some bits and pieces that we're going to be covering today. It's a really useful knowledge organiser, and if you are able to, that's something that you could print off and stick in your notebook. It's something that you could keep with you. It's like a little revision page, something to help you. Lots of language on there, really useful. Okay, so before we plough into the main part of the lesson, I want to just have a little bit of a recap, a little bit of a warm up, get your brains going. So this is a part of the video after I finish talking that you might want to pause and have a look at organising these light sources. So there's a light source, there's two different types of light source and non-light source. So I would like for you to be able to organise or to sort these objects into light sources and non-light sources. So if you'd like to pause the video now. Okay, so hopefully we would have done pretty well with that activity. So we've got mirror here. Hopefully we all can identify that, a mirror is a non-light source. Pencil is also a non-light source. A lit candle is a light source, but if it wasn't lit, then it would be a non-light source. We've got a television screen that has been turned on. That would be a light source, but it would be not a light source if it was turned off. The stars. Now, the stars is a bit of a tricky one. Stars, the majority, well, they are balls of burning gas, just like our sun, and so it is a light source. The moon is not a light source. We're going to have a look at that in a minute. The Earth is not a light source, and the sun is a light source. Okay, so the moon is not a light source because it does not make its own light. Instead, it reflects light from the sun, which is a light source. And from your previous learning in year 5, you'll all know about the space and the different phases of the moon, and that in fact we, the Earth, we block the light that's travelling to the moon, which is why the moon has different phases, and sometimes it's a full moon and sometimes it's not a full moon, depending on how that light is travelling and where we are. So objects that reflect light from light sources are sometimes called secondary light sources. So this is another point in the video where you might, in our lesson, where you might want to stop and pause. So we're just going to have a real quick recap. So light sources can be natural or man-made. So they can be natural or man-made. Can you make a list of natural light resources? And why do they produce light? So if you want to pause me here, you can. Okay, moving on. So light travels in a straight line from a light source, whether or not that's a man-made light source or a natural light source. And in this picture here, we can see that the Peace Tower in Iceland sends a high-powered beam of light into the night sky. You can also practice that at your own home, and you can see if you have a torch, you'd be able to see the straight line travelling from the torch across the room. It starts off really strong at the light source, and it gets weaker as it travels across the room. Okay, so light is a type of energy known as electromagnetic radiation. Now, that might sound really scary, like a really large word, but actually it's not. It's just a word that scientists use. So it's a really good one for you to try and remember too. So electromagnetic radiation. It's made up of photons, which are little particles of energy. And light travels as a wave. But unlike waves of water or sound, it does not need a medium to travel through. So waves are obviously created through water, aren't they? This means that light can travel through a vacuum, which is a completely airless space. So below, I've put a little picture of different waves, and each colour travels in a slightly different wave, but that is, although we can't see them, that is how the light travels in those different waves. There's also a picture there that you can see. Now, those are light beams. They're coming from a single light source, and I've got some more of those coming up. So here we go. So light waves travel out from sources of light in straight lines. Now that can either be a man-made source of light, or it can be a natural source of light. So here we've got two man-made sources of light, and we've also got a natural source of light, and that natural source of light is the sun. So these lines are often called rays or beams of light. Some quite nice pictures there. I wonder if you could find any more pictures online that demonstrate the lines or rays of beams of light. Okay, so how does light help us to see? So rays of light travel from a light source, for example, the sun, and hit objects around us. So for the moment, through Oscar's bedroom window, the sun is shining through the window and it's hitting the side of my face here. It's also surrounding the bedroom, which is why you can see all of me and the things behind me. The rays of light reflect or bounce off an object and then travel into our eyes. This reflection of light allows us to see the object. So here we go. There is the light traveling from the light source. In this instance, it's a man-made light source. It's a light bulb, and it's traveling towards it's filling the space. And in this space in particular, there is a chair. And because of that, the light from the light bulb travels in a straight line and hits the chair. The ray of light is reflected off the chair and travels in a straight line to the girl's eyes, enabling her to see the chair. So that is how this works. It works with anything. It doesn't have to be a chair. It doesn't have to be a light bulb. It can be the sunshine. Any source of light enables us to see objects. So can you describe how you can see some of the objects right now? You might want to pause me in a minute. So are the objects that you're seeing because you can see them from man-made light or from a natural light? You might want to pause me and have a think. Okay, so I've got a little experiment for us to do now, if you want to. This might not be something that you can do at home, but if you can do it at home, then that would be really good. So if you have any black thick paper or card at home, you can roll it up into a cylinder like a toilet roll. Place it, no Oscar. Place it on top of the and drop inside something. Make sure it is completely flat on the table or it will not work. So what do you notice? You can't see the object because there is no light getting to the object. So it's something that you could definitely try at home. If you want to pause me now and go and have a look, you can go and do that. I think it would work with a dark coloured piece of paper too. I'm not sure if it would work with it needs to be a darker piece of paper or cardboard, something thick, so that it doesn't allow the light to travel through. Okay, so on our home learning website, you have got an activity to do based on this little lesson that I've just been doing. So the Light Up Learning Lab. So you've got some sheets with different levels of ability. So you can either do, depending on how confident you're feeling. So if you're not feeling very confident at this and this subject that we've just looked at, you could go back and you could have a look at the video again. But then again, if you're not feeling very confident, you could start with the 1-star activity. If you're feeling middle-ish, okay, confident, then maybe you could start with a 2-star activity. And if you're feeling super confident, there's a 3-star activity there for you to do. So I would say that it would be really great for you to go ahead and do that now. Before I go, I've just got a couple of other little tasks that I can show you, and I would maybe help to extend your learning with this before our next little lesson. So it's over to you, scientists. Go and see what you can get up to. So we've got a task it section at the bottom. So got to make it section. So why not make a non-fiction book about how light travels and how we see? You could do this on lots of different objects that are around your home or around your bedroom. You could do a selection of different objects. You could draw pictures and diagrams to make your book more attractive, or even add pop-ups. So that you could do it just like a couple of slides ago with the lady in the chair. You could do something like that and label it and diagram it. Okay, and a little research it activity. Can you find out how fast light travels? And how long does it take for light from the sun to reach our eyes? Now, when I researched that, it took longer than I thought, so it's a very interesting thing. So can you find out how fast light travels? And how long does it take for light from the sun to reach our eyes? Mrs. Curley and I would absolutely love to see some of your work. So if you, as and when you complete your work, whether or not it's worksheets or whether or not it's the experiments or the make it or the research it, why not drop it in an email to us on the school website, and it would be, or via the school email address. We would absolutely love to see it, and then we can tweet it and you can see your work online. It would be absolutely amazing. Anyway, for now, that is me done, and I hope that you have had a great time. We will see you soon, and we hope that you take care. Bye bye, guys.